All right. So hi, everybody. I think we are going to go ahead and get started. Um, you are in the consistent reproducible workflows for geospatial stewardship session. I'm Julia Lowndes from OpenScapes, and I'm one of the co-conveners of this session. We have a really awesome team of folks, Rich Signell from the Open Science Computing, Jed Sundwall from Radiant Earth, Brianna Pagan from Development Seed, Kate Wing from Intertidal Agency, and also, and one last co-convener is Carl Bettinger from the University of California at Berkeley. And we're a group of interested data folks and teachers and builders. And really the goal for this session and the reason why we pitched this session was really to figure out how together to learn and build some new workflows around data preservation and reuse, and how we not only learn and build these things together, but then turn around and teach them together. So we're really lucky that Rich Signell is going to demo how he has put data into Source Co-op and accessed it beyond. And we'll see that for the first time. One of the goals of the session is to write notes and documentation of how this works. So we'll be using this Google Doc that you're able to access from Sketch. I will continue to put links of this Google Doc in the chat and answer questions in chat if you're on Zoom as well. So there's a couple, these are two mechanisms that you can ask questions in this session and also help us with documentation, help us figure out how, like what's still hard, what we need to think about more. So that's really the bulk of the session, and then we'll sort of take it from wherever the conversation goes and interest goes. First off, I'm gonna try to scroll here. Nope, that's not gonna show. Mouse. Thank you. Oh, there we go. First off, I'm going to welcome Kate Wing from Intertidal Agency, who's going to give an overview of the landscape of a lot of the work going on in the data preservation space. So thanks, Kate.
Oh, thank you very much. I'm curious, how many people in this room have been to one of the other sessions that has talked about like data resilience, data preservation, worked with EDGI, just kind of a quick show of hands, people online. Okay, in the room, a lot of people have been doing that. There is a little bit of a data resilience, data preservation track that's been going on for this conference. And so I'll be fairly brief because, as you can see in the collaborative notes doc, I put a couple links to the two main groups that we at Intertidal have been working with, the Data Rescue Project and Public Environmental Data Project, which the folks from Open Environmental Data Project and EDGI, Gretchen Gerke, and Katie Hoberling are here this week, as well as Gregory Maurer, who has been working with that as well. So there's other people who have been more deeply involved in some of the archiving. But I'll talk, yes. Oh, I will turn that on.
Oh, it's on.
Oh, it says the video's on. It's just, oh, the angle's wrong. Hello. And then datamatters.us, somebody, I believe, posted in the ESIP 2025 chat about a recent piece in The Hill from Joel Gurin, who runs a group called the Center for Open Data Enterprise. His group just released a report primarily authored by him, kind of surveying the current federal data landscape. I posted that to the main ESIP general Slack a few weeks ago, but it's also linked, or a week or so ago, it's also linked in that article from The Hill Code. And Joel Gurin's group has been working more broadly, not just on environmental data, looking at data across all sectors, all agencies, and working a lot with the National Statistical Agency Associations to track data efforts. So the link to dataindex.us is kind of an ancillary project to some of the work that Joel Gurin and the Center for Open Data Enterprise Code have been doing to use the mandatory requirements to report on changes in data and data services, which can be hard to find. Each agency and line office can do them differently. Some are required to be in the Federal Register, some are not. Some have stricter guidelines about what you have to say about what's going on and what's not. data index is trying to kind of scrape all that data and provide a centralized place for updates to changes in data, data services, and data products. So the short update I would say about the data preservation effort, if you went to the repository risk scorecard, if you followed any of the work that ESIP and other partners did back in 2017 during the first Trump administration, when there were initial concerns about data or data product being disappeared, this is something people have been working on for quite some time, thinking about the preservation and maintenance of key federal data and data services. The ESIP list of kind of priorities for thinking about data risk that have evolved into the repository risk scorecard grew out of some of those conversations. People are in this room who've worked heavily on those efforts. And that was kind of frameworks for thinking about risk. But what I will say sort of generally, particularly for this iteration of the data preservation community, is that it has very largely been request-based or based on what people with expertise with the data are looking to save. So an effort started shortly, even before the election in 2024, and then sped up after the election by both the Data Rescue Group, which is librarians, archivists, and other data preservationists, including Harvard's Dataverse, and Public Environmental Data Partners, which includes the Internet Archive, to look at what should be prioritized. And Public Environmental Data Partners has a priority on environmental justice and climate and environmental issues to start. So there's a coalition which is really anybody interested in preserving data. There are forms at both of these websites where you can say, I have data I'm concerned about. I would like help preserving it. I want to know where to find this data. And also at both of the websites for PEDP and Data Rescue Group, there are links to essentially a shared Airtable that they have integrated that shows what data has been preserved and where and how to access it and a contact information if that's made public. Another place that is, there is a lot of work being done in Europe around data archiving, and I know other folks in this panel may say a little bit more about how they're getting data off of BitTorrents and other servers, but just know that this is a global effort. People within the US are identifying priorities. People within these very volunteer-heavy coalitions are stepping up and saying, I can do this, I can document it, I can do what I can, but a lot of it are not data experts. They're not subject matter experts, or they're maybe not even really deep data experts. They know how to use Internet Archive tools or basic tools to essentially make a package and store it somewhere, but they might not know exactly what to get. So people who really know this data and know how it's used are important to have in these coalitions. Most of these coalitions have a fair amount of information security. There are people whose identity needs to be protected in order to give guidance about preserving and accessing data, and these groups take that very seriously. And so if this is a place or a thing that you're interested in getting involved with, these are two places you can start to get engaged. If you want to engage as a data expert and say, you know what, I know a lot about this data system, and I want to help you think about how to make it reusable going forward, that is sort of where these groups are now. It's sort of that a lot of the stuff that is easy to grab or that can be grabbed easily has been grabbed. And a lot of websites are just automatically crawled as part of the Internet Archive. So many things have been preserved in some way, shape, or form. But as one of the people who we've worked with a lot says, there's a difference between burying data in a jar in the backyard and a difference between making it something that you can cook with. So now people are really thinking a lot about if we've moved through this initial tranche of concern about things going away and we just have to grab it any way we can, how do we think about rebuilding? And how do we think about, even on a grander scale, restarting data collection programs that might be shelved? So these groups, and there are a number of other people in this room who I know are active in them too, are at that stage of conversation. What do we prioritize? Why? How do we rebuild things? So for people who know about that data, know who uses it, want to work with that data, these are places that you can engage and talk more about it. But for today's session, what I would say in part is that there's been a recognition that if you are someone who just loved to go to a website and get something about climate impacts on your community, in the same way that it might be good for you to have a fire extinguisher in your house and a safe place to meet if there's an earthquake, because I live in California and you need to know where to meet if there's no cell phone towers, it might also be good for you to know how to download and package data and where to talk to people about sharing that data. Because on one hand, it's great to have lots of backup of data. On the other hand, do we all need to have our own petabyte servers in our house to download all the data we need? So understanding how to be a good data steward and how to engage with communities and track like, oh, somebody already has this. Maybe I don't need to grab it, but maybe I should reach out to the person who has it to say, I can help you once you're ready to make that accessible again. That's where these communities are going now. Yes, I will introduce chat. I was just trying to see if I click on the chat, does that mess up the screen? Okay, there's nobody in the chat saying I have a lot of questions. Okay, great. Then I'm going to introduce Jed because if you're in the plenary, I don't need to say anything else about Jed, but Jed's our next speaker.
Okay. Yeah, I can click around a little bit. So hey everybody, thanks for coming. So yeah, I want to talk about sort of the vision for Source Cooperative. So first of all, have any of you ever like? Oh, okay. All right. Just a little bit. Raise of hands. Have any of you encountered Source Cooperative or used it? Okay, a few. Okay, great. So Source is in beta. It's been in beta for a long time. I'll just tell you my sort of sob story really quickly. Like, I left AWS about 3 years ago to take over Radiant Earth, and we've been in sort of in the process of the ambition of being trying to figure out, can we create really good software, data sharing, a really good data sharing service as a nonprofit? Can we raise enough money to build really good software? As opposed to what I've heard called things like professorware, or the kind of software that like typically gets produced by nonprofits. And what we're trying to do is create a pretty simple data publishing utility. And I'll just say this, it's gone somewhat slowly. We're very lucky to have very generous support from both AWS and Azure to have a lot of free cloud storage that we can use to host data. Over a petabyte of data is hosted in Source Cooperative. A lot of it is some rescued data. But building the interface. So if those of you who have encountered Source and have been there and it looks like it hasn't changed in a long time, it's just because it's slow to build software as a nonprofit because you don't have as much money as other firms do. But we're entering into an agreement with Development Seed, like right now. The contract is being written to accelerate development of it. But let me show it to you. Let's see, I can't. Yes. Okay. Come on, Zoom. Zoom just about.
Ian, what's the magic?
I got it. It's good. So like, this is what it looks like. So how many of you also have used like a cloud object store before, like S3 or anything like that? Okay, a lot of people, right? So one of the ways that we think about Source, or I conceptualize it for people, is that it's S3 for people who should never log into a cloud console, which is, I would say, most people. I do like to describe sort of cloud services as power tools, the same way like a laser cutter or table saw is a power tool. If you don't know what you're doing, there might be life-altering consequences to using it. And so, but for a lot of people that just want to share data, object storage is unbelievable. Like, you can share any data, any kind of data at any volume. It's extremely performant. It's available and accessible anywhere in the world. It scales really nicely. It is commoditized, and is generally continually getting better. So what we want to make possible is for people to do something quite simple, which is put files onto the internet and then have URLs that point to those files that they can share with people. And the concept of Source is very similar to like GitHub, where you have repositories, right? So I'll go down to this one because it's still our best demo after 2 years, but it's going to get better soon. But where you have the concept of a repository, it has a title that the Zoom thing is blocking me from seeing, but there you go.
It's Control-Alt-Shift-H for that. That works.
This is fine. Yeah, we're good here. Sorry, I just had to move the Zoom thing. But there's a title, you know who it came from, you know when it was published and things like that. You have a README. This is very similar to GitHub. And then also similar to GitHub, you can browse the files. Now, I'm not going to go into the difference between GitHub large file storage and files and the concepts of file storage and object storage. We can geek out about that if you want. The main difference between what you're seeing here with Source and GitHub, though, is that Source is built on object storage, so it can scale really, 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 really effectively, infinitely. What it can't do is, or at least what we're not doing right now, is very fine grained, like version control and collaboration and the kind of stuff that Git does. It's mostly designed for if you have a data product, an artifact that you want to put on the internet, you should be able to do it. And when you put it on Source, you just get this clean URL, and you can share that URL with somebody, and they can do whatever they want with it. But one thing that we want to do, we already do, and we want to do more of, is to also allow people to see data very easily. And so one of the tenets or like goals of the product is so that people can, if you get a source URL and you're like, oh, this is a source URL, I should know who published this data and when it was published, and I should be able to see it. What we want are for the users who encounter data to know very quickly, is this worth my time? Do I know what to do with this, and where can I go with this? And to the extent that we can, if people are sharing data in cloud optimized formats, we should be able to show them as much of the data as we can. And so this is a PM tiles file, which, as you can see, was uploaded in August 2024. It's about 237 gigabytes. I'm not going to attempt to download it on this laptop. But the beauty is you don't need to. You can zoom, because it's in a format that's cloud optimized. There's a format called PM tiles. You can effectively stream this data out and view it in the browser, and it's astonishing. You can zoom in anywhere in the world and see these vector building footprints. There's an issue with the viewer that we're working on that causes it to flicker like this sometimes, but you get the point. If we can, the goal though is to give people a very easy browser-based tool to be able to encounter very, very large volumes of data and interact with it. And this is conceptually kind of interesting in that, like, it's somewhere between an archive. It can serve as an archive, but it's really designed to be a place where data products are hosted and published for people to use. And really what we want and what we aspire to be is a canvas where people can work on the craft of creating great data products, which I think is something that's undervalued and understudied within our community and within science broadly, is that we've been talking a lot about you should publish your data for a long time, or thou shalt open your data, through policies and grant requirements and things like that. What we don't do and what we haven't done is studied, like, well, what makes great data products really great? There are things like the Landsat Archive, Collection 2. There are things like ImageNet, AlphaFold, Common Crawl. For those who recognize those names, they're like important brand names that have like led to step changes in science. And I think we're at a point where like we really need to be studying like what makes a great data product. And our goal with Source is to be a canvas for people to experiment with that and learn. I won't waste any more of our time here now talking about the business model. But right now we are in beta. We are subsidized by mostly AWS and Azure, but I want to give AWS the credit here because they've been very generous with us to be able to host this kind of stuff. And we're building it in public right now. And we're going to actually be launching a new front end, hopefully by the end of August, and moving a lot faster on feature development. But in the fullness of time, what we want to be able to do is have an offering that is like, it's an object storage offering where, like, if you want to publish data, you should pay for the amount of data that you have to use. Do I expect individual researchers to pay for it? Probably not. I mean, we'll have like a sort of like a retail, if you want to host a terabyte of data, it costs this much per month kind of thing. But ultimately, I think what we'd like to do is work more with funders and foundations, what we would consider like anchor tenants, to say like, hey, we're going to allocate a petabyte of storage to be published in Source Cooperative, and our fundees then are able to use that data to host it. So a lot of different ways to think about it. Another thing, and I talked about this at ESIP last year via video, and also, yeah, shout out to Chris Stoner who encouraged me to make that video. I am talking increasingly, and I think we're at an interesting point in history, as we all know. But talking to philanthropists about creating an endowment that can also undergird what we're doing here, which is that like we can no longer just kind of cross our fingers, then like hope that budgets get passed and things like that. we've been dealing with like weaponized budgets that have been sand in the gears of science for a very, very long time. And I'm really convinced that object storage and like these commoditized cloud technologies they're relatively young, but I'm really willing to bet on files on the internet via URLs being a really good way to share data for generations to come, and that endowing a governance layer that can ensure reliable access to data via URLs is something that we should be investing in. And I don't want to say, yeah, I'm like very hesitant to say like this is a great thing that's happening right now. But one thing that is happening right now is that the shocks that we've seen to the scientific infrastructure that we've taken for granted are finally waking up civil society and philanthropy to understand that this is something worth investing in and creating a more durable structure. And I think we're actually pretty overdue to do that. So I'll leave it at that, and we can have more discussions about the details later. So, Rich, over to you.
All right. We need to move this thing camera thing again, right? Does that work? I don't know. So I had seen Source Co-op, and so I knew what its kind of capabilities were, but and you know, I was just working away, kind of worried about what was happening with, you know, data disappearing. So I was keeping track of you know, these notices that go out. Like, and this is one of these ones that came out from NOAA in April. And, you know, I was looking at these, and a lot of them, I was like, whoa, wait a minute. Estuarine bathymetry is going away. It's so if you click on this, you know, this was from NOAA on April 15th. The product will be decommissioned. Estuarine bathymetry is being decommissioned, and the data will no longer be easily downloadable. The website retirement is May 5th. The archive data will only be available through an archive request to nci.info at noaa.gov. I kind of doubted that sending an email was going to get us the data, and even if it did, you know, what a horrible way to be able to obtain the estuarine bathymetry data. So when I saw this, I thought, well, here's a data set I actually care about, because I worked at the USGS for a long time, and I know we use this data set all the time for like making estuarine models and for looking at, you know, how we're going to do our work in these different regions. These are estuarine grids, bathymetry grids for all the major estuaries in the US. Took a lot of work to put these things together. They're not huge, but they deserve to be they deserve to be preserved, and I wanted to make sure that would happen. So I'd also heard from like Kate Wang and others about this, you know, the data rescue project, and so, you know, I tried to figure out a little bit about, okay, where, you know, has this data already been backed up somewhere? And they have this really cool spreadsheet, which you can, let's see, that, oh, I want to do the control, I'm going to try this, Control Alt Shift H, oh, beautiful. Okay, so this thing, you can filter on it, you can search on it. So like the first thing I did, I said, you know, this is just a spreadsheet, but, you know, I go up here and I typed in bathy. And I didn't even have to hit return. Beautiful interface. And so it turns out, hey, look at this. Estuarine bathymetric digital models, status finished. And let's see, so there's an ID over here, unique identifier. And let's see, if I scroll over here, actually, you know what? I can hide some of these fields I don't care about, like, because I just want to show you a little bit about how you might want to use this to find your own data. Like maybe I know it's NCI, I don't need to see that. I don't need to see the organization or the agency. Okay, now I can start seeing, I don't need to see the status. All right, so I see when this was backed up. There's two of them. One of them says 0.001 gigabytes. That doesn't sound too good. This one says 5 gigabytes, and it says who backed it up. Data rescue project, and SRC is that's the which one? Okay. It's okay. So this SRC organization is a German run sort of organized. I mean, it's international, right? But
name of it is in German, scholarly research preservation, but that's not actually the
Yeah, okay, so it's a, right, it's a, okay, so it's a scholarly research something in German. But anyway, it's, the thing that these guys do is they back up with, on this thing called PSYOP. And so PSYOP, let me just click over to that. So PSYOP, actually, let me go to about PSYOP. This is a really beautiful statement here. I'm just going to read it. PSYOP is made of a group of researchers, archivists, and hackers, all united in being information activists. Our goal is to ensure that our cultural, intellectual, and scientific heritage exists in multiple copies in multiple places. No single entity or group of entities should be allowed to make it disappear. Beautiful. And so here we have this group using BitTorrent to back up data. So this is I sort of think of this as the, what did you say, Kate? And this jar in the backyard or something. It's stored somewhere. And it's stored in a way that nobody can get, like no one person or organization can get rid of it. BitTorrent, it was kind of like, whoa, BitTorrent? Like, didn't I used to use that for music downloads? You know, and yes, I did. That was like after Napster, I think, right? The Napster went away, and then there was BitTorrent, but it's back, and they've added some stuff to it and made it really work out pretty well for archiving research data. So, so if you go into their data sets, actually, let's go into it this way. So here's a link to the upload for this. We click on this backup location. This should come up. Okay, so here comes up in PSYOP. So here it is. You know, it's got the description of the data set here, and it's over here. You can see how big it is, 4.8 gig again. You can see how many people actually have a full copy of this thing. There's 8 copies. So these seeders have the whole data set. And these downloaders are people who are downloading the data. And so the way BitTorrent works is when you're downloading, you're actually also sharing. So even if you don't want to be, just keep your server running with the full data set and let people be grabbing pieces of it. So these little pieces of the data set all over the place. And when you download the torrent, you're getting these little pieces from different places. So that's what made it so fast. Back in the day when there was tons of movies and everything being shared, you'd get it from like your neighbors and everything. So anyway, so there's a torrent here. So what I want to do is, download the torrent and push it to source repo. So actually first thought about doing it on like the USGS machine the WHOI Woods Hole Research, Woods Hole Oceanographic machine, where I still have an account on their supercomputer. I actually did go on there and just see if I could do a torrent. So, nope, that's blocked. Makes sense, right? So I was like, okay, do I want to do it on my own? I don't want to do it on my own computer. Like, I've got a crappy internet, and also I don't want to, I don't have a very big hard drive, right? So, so I thought, well, let's do it on the cloud, because we're going to put the data in a bucket. So, I can create a repo on Source Co-op and pick a region, and then I can fire up an instance on Amazon in that region, and download my torrent there. And I'm going to use Coiled to do that, because I love Coiled. It makes it super easy. This is, if you haven't heard of Coiled, this is really what I recommend to a lot of folks for their infrastructure needs. It brings like the power of the cloud to your desktop, to your laptop. You can just start bursting to cloud clusters. It doesn't, you don't have to sign up and bring a credit card or anything. You end up paying basically a little bit more on your like Amazon or Google or Azure bill if you use more than a certain amount of hours, which I have never used. So I've never really given Coil any money, which I feel a little bit bad about, because I really love the product. But you can sign up and use it, and you probably won't incur any like additional costs unless you really use it a lot. But actually, it actually, the groups that do use it usually end up saving money, because it does nice things like shutting down your instances and stuff like that when you're not using them. So Coiled. So I think we're ready then to go to the demo, which let's see. So I have here my this is something we're going to do later, but so I'm going to scroll past the part so you can't start doing it in advance. Basically, I'm just going to go to my laptop here. I have a terminal open, And I'm going to go ahead and start a notebook on the cloud. And I'm going to, let's see, coiled. Oh yeah, yep. Yep. Actually, you know what? I can go full screen on this too. Is that better? Still bigger?
You can go bigger. That would.
Okay, it's getting a little so basically, you know, I've just got a well, let's just, so I'm on, you know, I'm on the command line. I've got a terminal open. I'm running, actually, this is a Windows notebook, but I'm running this in Windows subsystem for Linux, but you could totally run this in PowerShell or whatever. And if you're on a Mac, you know, it would still work. And Linux, whatever. You install this coiled, you install coiled, which is with a, you can pip install coiled, or you can install it with Conda, which is what I like to do. So, and then you just can say things like, I'm going to say coiled notebook start. I'm going to pick my region. I'm going to pick US West 2, since that's where I'm going to put the data. And you can specify what VM type you want. And I'm going to pick a pretty small instance type, M5 X large. Actually, X large is probably bigger than I need, just for the, and that is, and I'm going to change this because that's not correct. So actually, you know what? I'm going to do it right now. I'm going to switch this. I think a large will be fine. And I'm going to do the software. This is a software environment that I've stored at coiled with our ESIP lab account. So this is ESIP 2025. And then the workspace is ESIP lab. So ESIP has some credits from Amazon. And, you know, this is what powers some of the ESIP lab activities. And here we're using the ESIP lab Amazon account to use coiled to launch a notebook anywhere we want. This is just one of the things you can do with coiled. You can also just call clusters from Python code, like on your laptop or whatever. But I find this really convenient. We're going to go ahead and do that, and it's going to come up and tell us. Actually, you know what? I'm going to pull my water up while it's starting up. It takes like a minute and a half. But it's nice, you know, it tells you what it's doing.
Will you just re-narrate for us while we're waiting? Sort of like maybe say again the commands, but also the big picture of, so you've launched Source Co-op and you're connected. How are you? Yeah.
Okay, so I haven't done anything with Source Co-op yet. Actually, you know what? Yeah, okay. Well, this will be okay. So so the way I'm launching it here is actually without providing any credentials. So to Source, so like, if you want to push something to Source, the steps are actually, you make a request. There's a form you fill out, and you say that I want to be able to create repos, and then probably you have a little conversation with Jed or something about, okay, how big are your, you know, how big of data sets are you talking about? Like, who, you know, why do you want? What are you going to do with this stuff? Who cares about them? And you know, at that point, then you create a repo. You saw Jed showed some repos. And if you own, you know, you can create a repo, and then you go in and it gives you a couple of basically just a key pair that you use for authentication. So I'm not going to write to the repo with this notebook, because the way I'm launching this notebook is I'm not providing any credentials. So I'm not going to be able to write to Source with this notebook. I'm going to show you sort of like how, what you can do is I can download from a torrent. I can run some visualization, and that's the part that you guys are going to do like later. And then maybe we decide that we want to push we want to find something on BitTorrent, and I'm gonna, you know, and then push another something else that we think might be useful that was in danger of you know, not being in a not very useful space. And so it's not going to be everything. A lot of the stuff on the BitTorrent is not stuff that you would really want to necessarily put on source. Like the stuff that I thought would be really good to put on source would be stuff that's in TIFFs or in .cdf files, like stuff that really should be living in some place where you can use byte range requests to go in and grab the data, because that's like the new architecture, right? Like there's a foundational layer of data that's accessible directly on object storage. And on top of that, we layer our services, and instead of, just having the service and then somehow other way to get the data or something that's like a download. Okay, so this thing has started up. So it has the link here. So we can just go ahead and click that link. And, we get the familiar JupyterLab interface. We don't have any, notebooks here. But we can, we can either just like drag something from our desktop, or we could go and like, I'm going to go to this repo here that I created for this demo. And I'm going to go back to the code. And you click this green button over here and grab I'm going to grab this one. So I've copied this to the clipboard. And I'm just going to go over here and clone the repo. I'm going to open up a terminal tab. And now I've just got, well, that's pretty tiny. Oop. Okay, and I'm going to just drop that in there. And then, whoops, git clone. And no, I don't want the news. Thank you. All right, and so over here now I have these, some code that I can look at. I'm going to look at this psyop to source little piece of code that I used to basically download the torrent and download the torrent and push it to source. And so this is going to be a totally ephemeral machine with ephemeral storage. Like, I'm not sure if I mentioned, like when I launched the notebook, I said how much disk I want. So I already knew it was 5 megabytes. I put in 50 just because, just in case. But, if it was a terabyte or something, then I could specify like I want a terabyte of disk. And, and again, so I'm going to download the torrent and push it out of the bucket and shut everything, just throw it all away. So psyop to source, okay. This is what, actually, this is just some additional redoing some of this information. So, so in this software environment that we referenced when we start up the notebook, which I created with a coiled create environment pointed to a conda environment file, and that environment file had a package called aria, which is a BitTorrent client. So, so actually it's a little bit funny, but I'm just basically calling this from the command line. I've got a, exclamation point aria2c in here, and I've got that torrent that I got from psyop. This is that long thing that ends in torrent, which I got, by browsing around in that spreadsheet, right? So I copied that over here. The seed times 0 basically just says download the data, and I'm not going to be like one of those seeders. So I'm not going to keep this machine running and to have a full copy and be a good guy and share it with everybody. No, I'm not. I'm going to be, there's another word for somebody who doesn't do that. That's not very nice. But I'm going to just grab it and then push it to the bucket. So we're going to do this. We're just going to hit this and download complete. No, we're not. Download complete. Oh, it's working anyway. Okay. That was a error code. That doesn't look good, did it? That really didn't look good. But here it comes anyway. So, so you can see its progress ticking along here. Estimated time to download 5 gigs to this machine. I don't know where this torrent is. I mean, it's coming. Well, it's not anywhere. It's like all over the place, right? So I don't really know where to launch a machine to like get the best, torrent performance or something. But so it might take a while, right? If you have a bigger data set, it's going to be, it's going to take a while, but that's okay. This machine that I'm running on, actually, if we go over to coiled, I think we can see this machine. I've got 2 of these running. Okay. I'll just leave them running. This one's up for 2 hours. Actually, I can shut that one down. That one's running for 2 hours, so I don't need that. I can stop the notebook. So another nice thing about Coiled is it has a really nice little interface here. I guess that's pretty small too. Oops, that doesn't look too good. But here's this notebook that I have running, and it's telling me it's been up for 7 minutes, and it's going to cost, oh my God, it's going to cost me 10 cents an hour. Dang it. So this stuff is cheap. So it's like three gigs of the 4.9. So what you can do here, once you've got the data downloaded to this machine running on the cloud, you could explore it here, right? Like a little bit before you decide whether or not you're going to push it to source. Maybe you probably, if you don't know what the data set is in advance, that'd probably be a good idea. Like I knew what this one was going to look like because I'd been working with this, but just one second, but like some of the other ones that look like they might be useful things to push to source, I have no idea if they would be reasonable or not. And so we could use this to do that. Yeah, Julie.
Thanks. Conceptually, so you're downloading it from SciOp to where before you put it to Source Co-op? Where are we downloading?
Yeah, so in this case, I did get approval to create a repo on Source Co-op, and we can go show how to create that later for another new data set. So I already created, I'm basically repeating the process that I used to push a data set to Source Co-op, okay? So I created that, I created a machine on the cloud to run this notebook that was running in the same region where I'm going to push the data to source. I mean, it doesn't make a huge difference probably, but why not? Because I can start it up anywhere. So I'm starting up a machine with limited like compute capability because it doesn't need much compute, but I'm starting it up in the region. The main reason I'm doing it this way is just because I wasn't able to do it on my HPC because they wouldn't let me. I don't want to do it on my personal computer because I might not have enough hard drive, and I really don't want to be sharing my IP and go through some weird VPN thing to try to hide my identity or something. So I'm just going to do it on the cloud. So I'm going to spin up this machine on the cloud with enough disk space and enough power to download the torrent, to push it to source, and then say goodbye.
I can chime in just for the people online. I mean, just in case it's not clear, like it is sort of evident in a lot of what Kate was talking about with data archiving efforts and things like this, is that there's a difference between archiving data and staging it for analysis. And that's kind of like the promise of the cloud potentially in object storage, is that you can sort of do both. Like it can be a very redundant place for data to be available for a very, very long time, very similar to an archive. But it's a different paradigm than saying like, this is here for you to get whenever you want. This is here for you to come and download whenever you want. Same thing in the context of like torrents. Like we have these torrents so that anybody should be able to get them whenever they want. The reality is, if you're working with very large data, torrents don't work very well. And the reality is also, people shouldn't have to download all of it to do their analysis. And so that is the dream of the cloud. I mean, it's been demonstrated for a long time that it's good for that. But as I said when I was explaining Source Cooperative, it's still too hard for people to take advantage of that. And that's, you're showing off how easy it could be now. It's still not that easy.
Yeah.
We've got some work to do.
Right.
Yeah.
Right. I mean, I had to figure it out too. I mean, it wasn't just like there weren't great instructions just for how to do this. That's a great point though, because like, yeah, once I put it on source, like to do this, like, okay, it's 5 gigabytes, but I probably cared about like Chesapeake Bay. I didn't care about all the rest of them, like, so like when you just want to be able to access what you need from this bigger data set. Yeah. And 5 gigs, maybe no big deal, but yeah, 100 gigs, 200 gigs, terabyte, you don't want to download a terabyte of torrent just to pull out like 5 megabytes of some sea surface height or something. So the thing is downloaded. So let's just actually take a look. We just go to the command line. We could actually just do ls and let's see.
One more question.
Yep.
So you've downloaded it. You had to download it somewhere,
Yep.
and so you made a bucket in the cloud to do that. And are you now unzipping?
No, I didn't. But no, I didn't make a bucket. No.
Sorry.
So this is just because this is just an ephemeral thing. Like, I actually didn't want a bucket. Like, and I'm sure there's a way to download a torrent to a bucket, but, this is a way. So yeah, there's probably better ways, who knows, to do this work. There's probably 100 ways to do it. But this is a way that I, you know, that made sense to me, that I knew how to do, that wouldn't take too long and worked. You know, so we're writing actually to a hard drive on the cloud. So we're not writing to object storage. So, oops, where is this data? Oh, there it is. Okay, so here it is. Like, you know, if we tab into this, you know, we see all these different. So this is on this computer on the cloud, right? That we're going to throw away. But I can see already, you know, I can see all the stuff. You know, I can see that, you know, the download of this thing worked. Tamales Bay, you know, oh, good. Here's a netcdf file, you know. So we could actually just go, like, if we wanted to poke around a little bit with this data before we tried to push it to source, we could, or we could, maybe we could like cloud optimize it if it needed to be cloud optimized. Like we could rechunk it. We could take a geotiff and convert it into a cog, right? We could do some stuff here. Maybe we need a little more resources. Maybe we could spin up, we need a DAS cluster to do the work. We could do all that here. I can spin up a cluster on Coiled right from this notebook, and it'll scale out to as many cores as I need to do those bigger jobs. Not doing that today, but you know, I could. So all we're going to do today, though, is, you know, as I was showing, you know, show you that basically all I did then at this point, and I'm not going to do this, you know, this step right now because I don't need to. I just ran this AWS S3 sync command, you know, and I just synced this folder to the source bucket that I had the, you know, permissions on. So, you know, it just looks like a regular S3, you know, I'm using the AWS CLI. And, you know, here it's going from here to here, S3 colon R signal S-stream bathymetry, which I had already created on source. I had created this repo and CEI S-stream bathymetry. And then you need to include this endpoint URL because it's not directly, it's actually, I don't know. You explain, yeah, you explain that part because it is on the AWS, but.
So one of the features of Source is that it has a data proxy. So it's designed to be a vendor agnostic solution. And so depending on where in Source you'd created that NCIS Estuarine, how do you say it? Estuarine?
Estrine?
Estuarine?
That's the way
Like that.
I see it.
Estuarine? Bathymetry repo. You could have, in theory, defined what region that's in, you know, and also like what cloud that's in and things like that. Source holds on to that information of sort of like, where should this go? And then as you upload it through the data.source.coop endpoint, which is, it goes through our proxy. So Source says, okay, here's some stuff coming in. I know where it's supposed to go and I'm going to put it there. And what this allows us to do is handle authentication and things like that. For those, maybe some people have been using Source. The proxy has been an issue over the past year. It sometimes fails, especially for like very large data set uploads. And so there is a likelihood that in the future we'll also add like a sort of like direct to the bucket option too, if you want, where you could say like, hey, no, I don't want to go through the proxy. Give me temporary credentials to just send it straight up to the bucket.
Yeah.
But anyway, that's what's going on at the proxy here.
Okay. Excellent. Thank you. And so I think at this point, so after I run this command, if I go back to source, you know, actually, you know, here I am logged in over here, which, you know, Signal, and I'm a member of this Pangeo organization. But if I click on Signal, I can see, here's my, I wonder where that came from actually. But anyway, here, oh, okay. So here are these data sets. Here's the NCIS stream bathymetry that I created. And if you click on that, you know, you get very small, you know, I have a little example of here of how to get this, you know, how to actually grab and start working with this data in Xarray, right? Which is my go-to. And that's part of the reason I wanted to push this data set because I knew that this data would be a good data set to use with Xarray. So, or would benefit from being exposed in the way that Source does so that you can use it effectively with tools like Xarray. And again, this is only 5 gigs, but you know, hopefully you get the idea. So if we go back to this little this notebook, then I basically just got those commands that you just saw there here. So I'm gonna use something called FS spec, which makes things look like a file system to make these S3 objects, again, look like a file system. So actually, if I put this in here, I can add a cell. And I can do things like FS read ls. And it'll tell me, see, now it looks like a file system. And there's something called S-stream, and NCI S-stream bathymetry. And if I put this in there instead, I can list stuff at that level. And then I see all, so you can confirm that it's basically looking at the same stuff that we just downloaded. Okay. Well, so we can look at it. I'm gonna clear the output. But then we can open it up directly in Xarray by saying fsread.open and then just going right to that netcdf file. So like, I'm going to go look at Buzzards Bay. So I can open it up in Xarray and it's open. And so let's add let's take a look at that data set. And there we go. It's two-dimensional data. It's got something called band1 is the data variable. And, not too much more info actually. So, but we can then visualize it right away. And I just want to show you some of the things you can do with data once it gets on things like source co-op. With a one-line command, hvplot, x equals x, the CRS that was used, the coordinates reference system. We're going to rasterize this data on the back end and deliver the pixels to the browser. We're going to put on an OpenStreetMap, and we're going to use a particular color map. You have to know how to do all that stuff, or maybe you don't. Just ask Gemini, and then you should get back. So now it's reading the data directly from source, and it's coming back, and it's going to give us something that looks kind of like, I have to make this a little smaller, sorry, so I can get to the widgets, but that's pretty cool. It looks like the data's in the right place. I've got a little OpenStreetMap on the back, the tile map service. I can hover over and I can see what the depth is wherever I'm hovering and what the latitude and longitude is. I can turn off that hover. I can use these little controls to like zoom in here. And when you zoom in, it redoes the color map so you can actually see what's going on with your data. It's pretty awesome for being able to just explore your data set, with like two lines of code, you're pulling some data from the cloud, you're, exploring your data in a real world map. So that's basically this little demo here. What I wanted to do is, would people be interested in just like running this yourself and maybe like exploring some of the other data sets on source this way with this? Because what I've done is I've created a token so you can fire up a notebook uncoiled on the ESIP Lab account and try running it yourself. That's one option. Another option is we could actually pick a data set, like look through the like SIOP data sets. We could find some other ones that might look good for putting on source and go through the process of creating a repo, getting the keys, doing that. Or we could just, do something else.
Thank you so much, Rich. This was awesome to see this for the first time. Thank you. Let's have a moment for questions before we dive into next portion. So are there questions? Okay, super.
Yeah. Hi, Corey Levinson from UC Davis. So a question that I have is just, I'd like to understand a bit. So source, as I understand it today, to write to source is kind of an invite procedure. And here we're talking about a reality where at least what we've been doing in this demo and maybe what's being provoked is like, okay, well, folks can anonymously be grabbing data sets and da-da-da-da. How in the reality of today's sources kind of invite-only closed beta, are you thinking about that both like in when we walk out of here today, but also in the next months or years? Like what's your sort of vision for that around authorship and provenance and stuff like, yeah.
Very important question. Should I stand up? I don't know. I feel like if you want me. So yeah, it's a super important question. We've actually gotten this feedback where people are like, oh, right now on source, a repository has an owner. So if you upload it, you're the owner of that repository, and people are like, hey man, you shouldn't say it's owner because like they might not own the data. And my answer is like, no. If you source, a huge part of source is provenance, is like being able, like we feel like it's our responsibility to say like, this is where this data came from. It came from Rich. Like if you've put your name on it, on that repo, like you've raised your hand to say like you're gonna have to answer questions about that data. And so I think this, like a lot of like the data rescue stuff that's going on where people are just like grabbing random copies of stuff and maybe acting as stewards of it is like a serious problem. And so it's so but the other thing is that like I think we have to get to a point, or we're getting out of this reality. It's been happening for a long time where like the source of data is like the government. It's like the only true source of data is a government agency that's producing some sort of product. When in reality, like data begets data. There's always lots of derived products and stuff like that. And so I don't know if there's a technological solution to say like this, where source can somehow know that this is data that came from Rich that he got from somewhere else. But if we can show that chain, that would be cool if we could do that technologically. Really what should happen, and what does happen now, is people are like, here's my data, I got it from this source. And they tell their own story about the provenance. Does that make sense? Okay. You, sir, and then Kate. Oh yeah, for the people, yeah, thanks.
Hi, yeah. I was wondering if you're using BitTorrent to grab this data and then upload it to Source Co-op. Is there going to be future efforts to support decentralized file sharing, like through Source Co-op? And has there been an exploration to, I know BitTorrent's not great for access, but there are decentralized things like IPFS that do answer the of like, yes, this is the same exact data from another source and has the decentralized aspect to it and can be used in like a real-time format, you know, like an actual file thing. Have y'all explored any of those?
So we worked with Filecoin Foundation pretty early on, and they started grabbing all of our data. Went back when we only had like a few hundred terabytes, and they're like, "Oh man, this is so much data." Like it didn't really work very well. So I think, especially for like large data products, where like to really do anything meaningful with it, you actually have to have 100 gigabytes of data or up. Like those fully distributed things just kind of stop working. Anyway, that's a space that we're not that interested in. I feel like IPFS and a lot of BitTorrent stuff is really designed for kind of like human consumable gigabyte scale data for the most part, and that's not a problem that we're trying to solve. We are also like, our thesis is that like decentralization is important and useful in some ways, but like there's real value in having a centralized platform that can have common APIs and an index and searchability and things like that. I think this is why like things like Mastodon have kind of floundered, while people prefer things, unfortunately, like X or Blue Sky or whatever. It just makes a lot of sense to have people working in the same space. But our answer to this is like, well, you have to distribute then the ownership and governance of it across many different parties instead. That's the way that we've thought about it. I'm not sure if I answered the entirety of your question. Oh, we could support torrenting though, I think theoretically, but it's not a priority right now. Brianna, yeah.
Yeah, and we do have a question online too, so I can pass that and we can go online. So yeah, maybe just also give like context on the session to go back to your question. I think a lot of the co-conveners, like we ended up convening this is because we were getting a lot of requests like from random people of like, I heard this data set's going down. And for all of us, for one reason or another, being pinged to like do something about it or ask like, what can we do about it? All from a very different angle. And like the question of just like being able to ensure someone's safety in this or like anonymity is like a huge open thing that we haven't figured out either. We've, I think, talked a little bit about using like the Pangeo as an organization that is just kind of like a trusted thing, but not really funded, and using that as an umbrella, but we still can't take away that someone has to have a privilege to know who's in that and making decisions. And so it's funny that I think a lot of this is more like people organizing open-ended questions that we're really struggling with on even what's the avenue to have these conversations to also ensure it. Is it going to be a private Discord? Is it like Slack? We haven't figured that out. So I do think that's part of the session and some context to this. So yeah.
I maybe just wanted to add, and what will perhaps in the future be the Kate and Jed talk about the data preservation movement
Sure.
show that we do, that, you know, as someone who does not come very much from the data management background, the other aspect of the issue of provenance, I mean, that comes up a lot, right? Like, what is the authoritative source and how do we document that? And for so many of the things that are going away, if you attended the session on publishing your first data set to Zenodo, which is another potential option, depending on the data types, right? Like what Rich is working with, great for source co-op. We have another project where we are literally backing up PDF files so that there's an administrative record copy. What if the Federal Register goes away, right? Like depending on what you're thinking about the future might look like, some files should go to different places. And then we get into the conversation about findability, right? What are going to be the places? And again, how do we document provenance? And I don't think there is a settled question. It's trying to make it as descriptive as possible and preserve as many of the identifiers and provide verifiability and kind of hope that this crowdsourcing, crowd checking, you know, we've talked a little bit in the data preservation community, but I don't know, some kind of like global checksum where like you
Yeah.
check all the
Yeah.
sources and 7 of them look like this. So this is probably the authoritative data.
I'd like to hear a little bit more on like, I also see, I think, a world where it's like, there could be a small project, maybe it is too much work to do, but just to have source co-op seeding a select list of the things that pop up on, or that to be an entry point where it's like, you know, if you were to do the technical connection between what it means to actually, okay, have something running on an instance, and I guess you need to then connect that to the object storage is technically what's happening here. But streamlining that would maybe cover some of the need to like have a source co-op use or like that. Yeah, I don't know. If anonymity is something that we're wanting to be preserving, then like actually BitTorrent is a really appropriate solution for that. If there's some ability for a community to say, oh, these are the things that have popped up on, is SciOp was the name of the service? These are the things that have popped up on SciOp. There's enough interest in having these accessible through a web interface, so the scientific community doesn't have to download a torrent client to access it. But you know, there's a more direct way.
Yeah, no, I like that. I mean, I think let me say this, like I totally understand and appreciate the need for anonymity and these communities and also like data rescue efforts and stuff like that. It's just, again, it's not something that we've decided not to focus on that for a variety of reasons. But and also, yes, like this is sort of what there's a discussion about this after the plenary as well. What about, you know, how do we know what data is good and what isn't good? And like we weirdly just don't have great systems for that. We don't have good markets that help us do that. And yeah, PSYOP is probably, and looking at the torrent, there's a lot of truth in that signal, right? Like, oh, this is data that people really care about. We should have another backup copy. I think that's a really good idea. Yeah. Or we should have another backup copy that maybe the Pangeo community decides to host. And there's some shielding of who's involved with it. And yeah, that makes sense.
Yeah, I will say that on this, there was some like, on this particular data set, there was a lot of like frantic email going around at USGS, you know, what are we going to do about this? And then, you know, when I sent them this notebook, you know, like you just have to change this URL. They were like, oh my God, you know, thank you. You know, it was really, yeah, it was nice. So, I mean, do people want to try running a notebook and playing around with source data, looking at some other, you know, you could see, actually, I'm just kind of curious if it works. So if somebody wants to try it, I'd be happy. But you could try it while we're having like another, you know, other discussion or something, but,
and I'll just build from that, Rich, just as a sort of facilitation. If somebody does want to run it and screen share what you learn and we'll see what's hard, that would be super and one way to look at this. I think also like having a clear sense of steps involved. So like, where did you go? What did you need to have set up? What tools did you choose versus have to use? Just so that we can think about these steps and streamlining them.
I kind of have a question going a little bit back to the source co-op part. If for you said you're running a data proxy, correct? And so is the hope to eventually have lots of, like, would institutions be eligible to help back through that data proxy as well? Or is that kind of antithetical to the idea of source co-op based on, your talk this morning and whatnot?
I want to make sure I understand the question. Would institutions be able to what through the proxy?
Yeah, sorry. Do a duet. Yeah. I guess so. You're right now got AWS, Azure, right? There's a lot of institutions with lots of storage capacity, and is the hope to kind of broadly diversify that into like a very like vibrant ecosystem of data backers, or is it supposed to be more centralized?
Yeah, that is yeah, again, it's interesting to think about like the ways to decentralize and like how to do it right. I'll share the full fantastical vision. So the short answer is yes. If you are running an S3 a storage service that has an S3 compatible API like Ceph or Minio, there are a bunch of these things, and we can read and list your buckets, there's no reason why we couldn't put them on source and like register them on source. There would have to be we would have to figure out the economics of that because the proxy, we pay for the bandwidth and stuff through the proxy. So like there would be like a cost to that registration, but that's why it's a cooperative. It's like you should join the cooperative and we can handle the proxy and gate traffic and give you metrics and do other cool stuff like that. The full vision is though that it's like, look, if you want to bring your own storage and you're willing to do that, like you can, and you pay for your own storage and there's the registration fee. I expect a lot of people aren't going to want to do that. And they just be like, why don't you just handle the storage for us and use the cloud that we tell you to use? And that would be an economic model for us. But in terms of like, again, centralization and decentralization, I think the main centralized function I really want to be endowed. Like, and I think there's a case to be made here where we can say like, we're going to maintain this proxy and basically a catalog and various indices, because it's indexing the stuff is going to be complicated, but of like potentially like quadrillions of objects. And the point of the proxy is to be able to create persistent URLs that, if endowed, could last for like 50 years. Where it's like, and we have the checksum, and like this URL will resolve and will return data today and tomorrow and the next day for 50 years. Like I'm just fantasizing right now, but yeah, that's the big vision. I don't think it's impossible. No problem. This is my 50-year URL crowd. I normally don't like share this vision with people. They're like, what are you talking about? And I'm like, but yeah, I know people here would be like, wow, a 50-year guarantee URL would be awesome.
So anybody want to give this a try? If you want to give it a try, I put the link into the meeting notes here. And basically, you're going to want to go to that link because there's like some stuff to type. But I don't know. Or Julie, what do you think? You want to take this in a different direction, or you want to?
I think the room should decide. What do we all need for the next step?
Maybe the room wants to go to lunch early.
Yeah.
Oh, yes.
Okay, yeah, there's, I think, a few open things to at least either leave with ideas or like next steps and things like that. One is, all of this stuff is great, and like where my heart is like on the searchability of the data, and obviously like that's not being tackled here. So right, we have existing standards like Stack or using CMR, right? That's how users are used to actually grabbing the data or being able to query it. And so I would love for that to also be a priority, is how to emulate like cataloging and making sure that anything going in source is also using, community cataloging techniques that are already existing to help with the searchability. I'm also coming from like hard science background. So like for me, when I see things like coiled and stuff like that to me is still a barrier in terms of like people not being able to maybe as quickly get upstarted with processes like this. And I also just wanted to like point out that, you know, Coiled is basically a paid version of Dask because open source software. So that's also just like an optional layer of this to help make things faster, but totally also understand people in, you know, government hats, like you don't have access to Coiled, like that's just how it is. And so there are other ways of using this process. Gonna plug one thing for Development Seed is that we do have projects that are called labs. And I basically we're able to, there's enough community backing, spend a little bit of our time to investigate something. And we recently opened a ticket around provenance and like checksum of checksums, basically. And it's from conversations that we've had with Google Earth Engine, with Microsoft, with AWS, and beyond checksums, right? We're like entering a world of there's Kerchunk, there's virtualizr. And so you don't have this one-to-one mapping of files to be able to actually look at checksums. So there's innovation needed on the technology side on how to handle that. But then also needing some sort of third-party system or code to actually give you like a green check that the data from the authoritative source is also like mapped correctly in. So there's like innovative work. And if that resonates with you, you can definitely come talk to me. I'd love to hear other perspectives. And the last thing is there was a session going on in parallel right now that was very similar themed. I'll get my phone and get the name of it. And I ran upstairs in an effort of seeing like, could we maybe combine forces or something and listen to each other? Obviously, it's the last minute to do that, but they do have a second part of their session at 4 p.m. And it's the Research Data Management Systems, a hands-on session on how to replicate data across similar systems. And so they are doing 2 hands-on demos at that time, and they offered to give us space for Rich to actually maybe go through the full demo, or just want to throw it out there. People also online and people in the room that maybe that's a good second part if you're interested in this topic to go to their session and also hear what they're doing, and we can learn from each other, etc. Oh, I think that's it.
That just did remind me though that just to follow on to that, yeah, you totally don't need to have Coiled. You don't even need to have a machine on the cloud, right? Like you could do this work anywhere. You could do those commands anywhere. It was just, you know, for the reasons I mentioned before, that's why I chose to do it on the cloud and use Coiled. But and the other thing is, yes, actually, I opened these netcdf files directly from the bucket, but as Brianna just mentioned, for bigger netcdf files, you wouldn't want to do that. It's pretty inefficient to do it that way, and you'd want to create references and push those also to the bucket.
One other thing is Joseph Gum sort of induced me into hosting a capstone session tomorrow, where we're going to try to just bring everyone together and kind of see, you know, what are the summaries from all these different sessions. And you know, I'm not going to be adding much content other than just being a vessel to bring us all together. So do come by Friday for that, and so we can kind of see what can we gel from all the different sessions that have happened this week.
All right, thanks everybody.